that this guy will buy. The packaging starts even before you make the payment. It is that kind of efficiency that we are talking about. It is that kind of insights that people have about us, right? A little bit more awareness in terms of how it changes in the industrial context compared to the consumer world, because that's the playground that we play in, right? A cell phone typically would have around 6 sensors, right? A gyro, compass and all that. Compared to that, a simple motor that we sell to the industries today has 2000 data points, multiple sensors every second generating this data, right? This is purely the data generated by Siemens systems. I'm not talking about the world data. No, this is not save the world thing. It is purely generated by Siemens. So we use our SCADA systems run the particle accelerator. You might have heard that, right? So we have one of the world's largest SCADA system deployment here at CERN, and actually it is capable, or not capable, it actually generates 1 petabyte a minute if I'm not wrong, but that's there in Google, you can check. But we currently do not have so much of compute, so it's discarded, and you see 100, and then there is a 2 there. 2 is actually 2 gigabytes per day. So 100 gigabytes per day is the data that is generated by just the Siemens system, and obviously, finding God particle is not okay. Finding God particle is not just on Siemens. So now, what is the expectation? What are customers expressing to us? What do they want? These are some of the high-level requests that come our way. Reducing time to market. Like as Mr. Prasad spoke about, for an MRI it might be 3 years, but then shaving off 3 months in that 3 years is great. Never heard of. Humanity has never heard of this. And for a cell phone, probably it is 3 months. And shaving off like 24 hours out of that, and then bringing it on Thanksgiving or Diwali, big billion will change the fortunes. Enhancing flexibility, I spoke about this, where you have a batch production of 1, right? And as I said, this is not something that is Vision 2020, 2025. No, our own factory in Kalwa does this. And I have personally seen this, batch size of 1. We manufacture contactors, batch size of 1. You can sequence it, and then you can walk with the product as it is being built. You can walk with it, and then at the end of it, 1 contactor is built. We can manufacture 180 combinations in that just by tweaking. Code, nothing. You have to just use your system, and then the whole assembly line just manufactures 1 product. Increasing quality, you know better, so I better not preach to the choir, so I'll just skip that. Increasing efficiency. Of course, there are challenges on how you can, to what extent you can go. This is again like scoring marks. From 60 to 80 is fine. People, most of them do it. But from 80 to 81, 82, 95, it becomes exponentially difficult. Okay, so the next slide, and then I have a video. I think I have like 5 minutes, so I have to wrap up. I have a video that will explain the digital twin and how real that is. But I will take the next slide and explain what we offer and how consumers can use it. Consumers for us is not the end user, because we are a B2B, so other businesses. Now let's take the example of a small scale industry or a medium scale enterprise in a country like Germany, right? So where they are really good, say for example Stedler, they make world class writing instruments, pencils, pens, your geometry equipments and so on and so forth. That's their passion, and they've been doing it for 200 years. Now if I go and sell them digitalization, and if I go and sell them like we can save the world together, let us do this, they would not be easily interested. And that is where companies like ours step in. So what do? We have a magic formula. We abstract, we hide the complexities, and we give them a easy to use interface, which is what Amazon did, right? It's not that nobody knew how to set up a server. It's not that Amazon showed us how to set up servers. Everybody knew that. But what did Amazon do? Amazon abstracted all the complexity and then just gave you a simple interface which you can use. This is what we have also been doing, and in fact those of you who might have visited our booth outside might have seen this in action. So what are we doing with Industrial Internet of Things? Connect, collect, analyze. Simple. Connect the assets, actually it was oversimplified, but then still. Connect the assets, but unfortunately all the assets don't speak the same language. They have different languages, which we call protocols. So somebody speaks some protocol, Mitsubishi doesn't speak my protocol, ABB doesn't speak my protocol, and so on and so forth, but there are still other standards. So that is connect. Connect all the devices. Collect the data, right? Get all the data into a place where it is safe, secure, and easily handled. Most of us are able to do these two, but there is a lot of complexity. A Stedtler will not do this. He will not go there and say, no, yeah, I will connect 5 motors. No, they will not do. Connect, collect, but that is not where the value is. Value is in analysis. What are the types of insights we can throw? How can we predict, or how accurately can we predict the failure of a motor? How accurately can we predict the consumption pattern? How can we tell them if the consumption pattern changes, what is the impact? What is the impact on the production, right? So what we have done is we have abstracted all of this, right? So there is data management. Now, whatever is there in the sub items, a person using it should not know that. It should be abstracted. So we put all of it and then we give data management, services and compute resources. Obviously, we are not the leaders in compute resources. Siemens doesn't make, or rather, we don't sell compute. So what do? We use Amazon, we use Azure, we use Ali Cloud, whoever is the leader. So we abstract all of that. Identity and access management. This is a big pain because once you have connected systems, and thanks to Hollywood, you know how systems can be hacked. So, it's a problem. So we do all the engineering that is behind that. Connectivity, this is what I was talking about. All the development practices, how do we build this, whatever is included, right? Third-party integration. Today, it's the world where we make applications available, we make it truly democratic. Anybody in the world who has the best algorithm to predict the failure of a motor is welcome. They can come in, build the app and sell it, just like Play Store, just like you would buy something on Play Store. It is available here. So now this is one way of doing it, right? So just leave all the dirty work and the complex engineering to companies which understand or which know, and then you focus on building the models. Don't get your hands dirty on things that you don't have to. So this is what it is. Now, as I said, I'm running out of time. I have a video which actually explains the real use case that we handled for Maserati with digital twin. Mr. Prasad also mentioned digital twin briefly, so I would see if the video can be played. Yeah? Should I go to next? Okay. No, but I don't have time for all the engineering. So it's like a 3-minute video and should explain how we do while they are trying to fix it. So we do a product twin. So basically, before you actually build the product, how do you create the twin? So we have a suite of software applications which can do that. Then there is a production twin, because this will also have to be built in the real factory, right? So there is a production line. How do we set that up? And then there is a performance twin, because as it is used, the data should be collected from the field and should be fed back to the first point on how the design started. So if it's a controller like this or a water bottle, then things are not that complex, because you will not be collecting so many parameters from the field, right? But when it comes to something like a car or an industrial controller, there are so many things that can happen, like a turbine, right? So our software suite is capable of doing that, and we have an entire portfolio for product, production, and performance. Now, performance is where it becomes like really next gen, as it is generally in the case. Okay, good.
Now, I think first and foremost with the Ghibli, we wanted to produce a new Maserati, meaning that the Ghibli adheres to the core brand values of Maserati, being Italian style, dynamic performance, and refined luxury. The challenge, obviously, in terms of launching higher volume cars within a modern manufacturing facility, state-of-the-art manufacturing facility, is to retain that bespoke feeling within the cars, which is very much appreciated by our clients.
Being able to work in a digital twin is a significant evolution compared with the past. By using integrated software such as NX and Teamcenter, we can have an interface of all the teams developing the project on the same mathematical base. This allows us to reduce analysis times and to avoid possible errors caused by miscommunication between the different teams.
We can say that one of the strong points of Siemens is the fact that we offer a product portfolio which covers both the manufacturing and the engineering side. And what's more, that these products are also tightly integrated.
L'impatto degli strumenti Technomatics.
The Technomatics tools are above all useful in the analysis of the product and in the simulation of the product line. Earlier planning and development know-how is thereby incorporated and implemented in the overall design.
Utilizzare l'esperienza del plant nel design
The aim was to produce 3 times as many cars than before, while maintaining the same level of quality, which is obviously higher simply because it is a Maserati.
Well, CAS is an integrated system used by the entire Fiat Chrysler Automobiles group and is also installed in the Maserati plant. It facilitates the management of the plant with Siemens PLC and HMI hardware with WinCC and Step 7, delivering all the diagnostics of everything that happens in the plant in real time. So Siemens technology helps us to be more efficient and have better quality management in the production plants.
The expertise is not only in the tool, so not only in the software, but above all, about how to use the software within the setting of Maserati and FCA, because that is where we really make the difference.
Thank you. So basically, the point of putting it up there, of course, it was slick US-made video, could have made a great impression if I had played it in the beginning, but that was not the point. The point of putting it up there is because this whole thing of a process twin, a product twin, a production twin, and a performance twin, it is not science fiction. So this whole thing, and it's there on YouTube, you can actually watch that video, because I doubt if the sound system was so clear that you got all of it. So it's real, and we shaved off 30% time to market for this particular model. The other tidbit is also the HMI panel and the WinCC software is all built here in our office here in Electronic City. So that brings me to the end of the talk. Thank you.
Thank you, Chetan. A very well delivered talk on the combination of reality, digitalization, and industrial Internet of Things. So just to reiterate points, Chetan, you talked to us about the challenges of digitalization, and you gave us examples, real-time examples of what new business models are. You told us how people are looking at to thrive in the digital world, and predictions and informatics and how that is changing digital life and daily life. You also gave the magic formula for us on how hiding complexity and giving simple interfaces can make a big difference in user experience to the world, wherein you connect, collect and analyze, as you put it. And yes, you did touch upon the objectives end of the day of digitalization, which was to reduce time to market, to enhance flexibility, increase quality, and of course increase efficiency. You summarized it very well for us with collaborative and attractiveness by delivering out an example of a video which gave a 30% time to market result from your case studies. Thank you very much, Chetan. I now request our President, Madhup, to hand over a token of acknowledging our gratitude to Chetan. Chetan, please come over. Madhup, please come over on stage.
Thank you, Mr. Chetan. That was an enlightening session. It's indeed getting very interesting as the day is progressing. Coming next is a panel discussion on connected devices, the changing landscape of the world we live in. Our eminent panelists are Mr. Ashwin Ramachandra, Vice President and Head of Product Engineering Services, Saskin Technologies, Mr. UK Kalyana Ramudu, Senior Advisor and former Vice President, Defence and Aerospace, L&T. I request our advisory group member and session chair, Mr. S.M. Balasubramanian, to join us on stage and introduce our speakers to us. Mr. S.M. Balasubramanian, Chairman and Chief Mentor of Digital Core Technologies, is a telecom engineer from College of Engineering, Gindi, Chennai, IIT Madras, and has done his management studies at IIM Bangalore. In a career spanning over 35 years, he has worked with ITI Limited in the R&D division and Wipro Technologies, Bangalore. He has held senior management roles in R&D partnership, competency development, process and product quality assurance, and high-tech product development. He was a master black belt at Wipro in Six Sigma methodology and a certified lean facilitator. When superannuated from Wipro in 2012, he was a vice president and a leader of the quality and business excellence function for the organization. Mr. Bala currently mentors a number of organizations, including startups and mature organizations, in all aspects of operational and business excellence. He also devotes his time to teaching, training, driving professional associations, and pro bono consulting. He is a keynote speaker in various international and national conferences. Request you to please come over, sir.
Thank you, Pooja. It's my privilege to moderate this session. As you could recognize from the title of the session, this is about Internet of Things. And we have two very experienced people from different segments of the industry sharing their experience and thoughts on the industrial IoT. Let me welcome Mr. Ashwin Ramchandra, Vice President, Product Engineering Services from Sasken, and UK Kalyan Ramadu, Senior Advisor of L&T for the Defense and Aerospace Division, to come on the dais, please. The way we'll have this panel discussion is that I'll start with introducing the speakers, followed by that I would request them to give their experience of the introduction of IoT in their own segments and what they see the evolution of IoT and what the future is likely to be in the area of Internet of Things. This will be followed by a few questions from my side, and I'll throw open the floor to the audience for a few questions, and then we will summarize with their closing remarks. So that will be the sequence we will be following. To begin with, I would be very glad to introduce Mr. Ashwin Ramchandra, Vice President and Head of Product Engineering Services at Sasken Technologies. Ashwin heads the PES at Sasken. He has made immense contribution in the various teams that has been a part of. As part of the Nautil team, he transformed from an engineer to an architect in the 3G and dual mode protocol stacks. Incidentally, I was also in the Nautil lab in Wipro. That's what I shared with you. He has dabbled in the technical marketing for the product division before moving on to the portfolio team for Sasken's Future Phones offering. Besides, he has had a productive stint as a business manager, and prior to Sasken, Ashwin claims to have spent a year soul searching and working with the Texas Instruments in parallel. Ashwin holds a bachelor's and master's degree in computer science. In his spare time, he enjoys watching movies and critiquing them. Besides, Ashwin travels every time he has an opportunity to do so. Thank you, Ashwin, for coming over. Mr. Kalyan Ramadu is an MTech in Communication Engineering and Radar from IIT Madras, and incidentally my classmate, and a BA Honours in Electronics and Communication Engineering from Madurai University. He has a total of 40 years of rich experience in the defense and aerospace systems. He brought up a new unit, Strategic Electronics Center, Bangalore, as a part of L&T's defense group. After superannuating as Vice President heading the L&T Defense Bangalore Division, he is continuing as a Senior Advisor to L&T Defense. His focus areas include design, development, and production of military systems, spreading in sensors, tactical radios, tactical wireless networks, tactical communication system, battlefield management system, and C4I systems. Prior to joining L&T, he worked for 27 years in Bharat Electronics, Bangalore, involving in many military development programs, jointly with the DRDO, such as surveillance and tracking radars, naval fire control system, command and control, and EW systems. He was instrumental in bringing up BEL Software Technology Center in Bangalore, and I think that was part of B-Spin for a long time. Probably it should come back to B-Spin again. Thank you for joining, Kalyan Ramadu. Let me start with requesting Ashwin to share his experience of the evolution of the connected devices, translating as Internet of Things, in the product organization, both in the consumer market as well as in the professional markets. Being the head of product engineering services in a services company like Sasken, he has a good view of the plans and the vision of the product companies in utilizing this new technology, IoT, in improving the life for both consumers as well as the B2B. So I would like to request him to share his experience and what he sees as the things to go forward in both in the consumer market as well as in the professional segment. The deployment of connected devices and how IoT is going to change the world we are living in. Request Ashwin.
Comfortable. I guess I'll start. Yeah. It's working? Yes. Thanks. So yeah, what I want to do is talk to you a little bit about the technology changes that we've seen over the last 15 years, right? And I can remember about 20 years back, 15 years back when I started working the computers, we were doing probably like it was 800 megahertz. That's what we had. That was a cool thing to have, PCAT, PCXT. And then that went from there to a Celeron, to a single core. I'm just talking compute, right? We're just talking about various aspects that make up the technology of getting to IoT. So let me sort of trace back and tell you how the world is moving and why IoT is, in a way, orthogonal to everything that's happening in the world at this point in time. So just look at computing. Went from 800 megahertz to a gig, and then it became dual core, then became quad core, and then most of you are carrying phones that are probably octa core, and it's getting worse. It's just increasing. So the complexity and the compute power available is increasing. Right? That's the trend that we're seeing in everything else. The phones that we have, the cameras that we have, any devices that we have, Alexa at home, immense amount of computing power. That's there. That's sort of becoming complex over there. Let's look at another parameter, right? Because the world in the last 20 years has changed quite drastically on these two parameters and enabled almost everything. Every experience that you have is driven by how much compute power is available and how much communicate or the channel that's available, right? So I'm going to trace back and look at 2G. We had 2G, there was no data in those days, right? We used to have something called WAP. Anybody remembers WAP? It was like an ancient protocol that was there. Then it became what is called as GPRS, and then it became Edge, which is 2.75G, then went to 3G. That's where I started my career. I started my career trying to figure out and build a 3G system for Sasken way back in '99. That took like about 10 years to roll out. We were still not at megabits, we were at 250 kilobits. And then it went to HSPA, which was 3.5G. We are now in LTE, the era of LTE. We're like getting to Mbps, and 5G is around the corner, right? So compute just increased, right? You have quad core, octa core, increase, right? It just keeps going up, the curve is going up, Moore's law. Communication channel just increased, went from probably 12 kilobits all the way up to 1 Mbps and even more. We're looking at 200 Mbps as we start practically, right? I'm not looking at theoretical speeds. And that's what it was. The world needed that because we needed better phones, we needed better cars, better computers, etc. And we had to consume more video. I've seen a lot of kids these days just constantly. I just don't know how the attention span for these guys work. They're switching between Facebook and WhatsApp and continuously checking stuff on an ongoing basis. And then here comes IoT. And let's look at the characteristics of IoT, right? It's actually nothing to do with anything that I said. It's very interesting. While the world and the technology is in this wave of just going up and becoming more and more complex, more faster, more better, IoT said, hey, hold on, you know what? And let me just step back a little bit and actually talk to you about the two parts of IoT. There's a part of the cloud, which is, Mr. Chetan here covered it really well about the analysis part, and I'm going to go reverse, right? Analysis is all happens